Hello dear friends, welcome my channels. Today's discussion is csir-net plus gate examinations questions. Net examination question. So friends, I choose 7 questions. I want to solve this all questions. Please watch carefully and clear the concept, because concept is very important for csir-net gate examinations. So let's start to solve the questions. Now let A be a square matrix such that det xi minus a is equal to x to the power 4 x minus 1 whole square x minus 2 whole cube, where det m denotes the determinant of a square matrix M. So friends, here in the question is wrong that rank of a square greater than rank of a cube equals to rank of a to the power 4. This is wrong. Pattern is this way, because we know if you property of rank is rank of AB equals to mean of rank of A and rank of A. So if I take B equals to A, so rank of A square is equal to mean value. So mean value of rank of A into rank of A, that implies less than rank of A. So rank of A square. So rank of A cube is also, therefore rank of A cube is less than rank of A square, friends. So we see rank of A square. So the rank of A square is less than rank of A cube equals to rank of A to the power 4. This is correct. This question is wrong in gate examinations. So I corrected this, and now I will solve, because this question is very conceptual questions, friends. Whatever you see that x to the power 4 whole square and x minus 2 whole cube. So friends, must remember key point. I write key point. When rank is given, asking geometric multiplicity, then we choose JCF. JCF means Jordan canonical form. So friends, here GM of, they ask then the geometric multiplicity of eigenvalue of 0 of A. So how can I find out geometric multiplicity? So friends, you see that 1 is AM of 1 equals to 2, AM of 2 equals to 3, AM of 0 equals to 4. So friends, our dimension is in here 4 plus 3, 7, 9. So my JCF is 9 cross 9 matrix, and where m of 2 am of 2 and am of 1 is equal to 2 and 3. So friends, I want to take only and 0 is my 0 is here 1 2 3 4. So friends, I just remove this part because for this part my rank is 5. 2 plus 3 5. My rank is 5 already because 5 non-zero element I have already, non-zero eigenvalue, 5 non-zero eigenvalue. So 5 non-zero eigenvalue is 5 non-zero eigenvalue. So 5 non-zero eigenvalue means rank is always 5, not rank is always greater than 5. So friends, now I have to choose that how can I solve. So possibility, so actually I have to write the given conditions. What is my given conditions? Rank of a square less than rank of, sorry, not less than rank of a cube equals to rank of a to the power 4. So friends, you must remember this is my conditions. So my possible Jordan block, there is 4 matrix, and let's see that any others is given. No. So friends, I have 4 0. So possible Jordan block will become possible Jordan block, possible JCF 1 2 3 4. This is my 4 Jordan block, 4 0, and possible Jordan block is, suppose possible Jordan block is only 1. Jordan block JCF is only 1, means this matrix is, this is the way 4 cross 4 matrix. Suppose my possible Jordan block is 4 cross 4, that my minimal polynomial, a minimal polynomial is mean A is equal to x to the power 4, my possible minimal polynomial. So friends, you can see that this is my A. So A square is equal to, if I will multiply, so whatever I get, you will write in here another A 0 0 0 0. So this is 0, this is 0, this is 0, and my minimal polynomial should be x cube, x square, and x. This is my possible minimal polynomial. If I will choose at first, this is the x to the power 4, then this relationship, then you will, if you will multiply, I don't have so much time, you will write in here 0 0 0 0 0 0 0 0. If you will multiply, then this relationship does not hold. If minimal polynomial, if mean a is equal to x to the power 4, and if mean is equal to x, so what is my Jordan? If mean is equal to x, then my Jordan canonical block is 0 0 0 0 0 and 0. This is my Jordan canonical form. So if mean x is equal to 0 0 0, my Jordan canonical form is 4. So friends, whatever you see, that this is does not hold, because rank of A is equal to 5 is equal to rank of A cube is equal to 5, and rank of A to the power 4 equals to 5. So this is not hold, and mean x to the power 4 does not hold. If my minimal polynomial is x square, so whatever I get, friends, my possibility is 0 1 0 0, another is 0 1 0 0. This is my one possibility. Another possibility is 0 1 0 0 and 0 0 0. This is my another possibility, friends. This is my total 2 possibilities. And if you see that this process, we get this relationship. This relationship hold when we see that when this process, we get rank of A. Suppose I take it is x. This process is x. So rank of x is equal to rank of x square is rank of a cube x cube, means this probability hold x a cube and equals to rank of a to the power 4. So friends, my Jordan block is 1 2. 2 means because that number of Jordan block equals to number of geometric the number of Jordan block of lambda is equal to number of geometric multiplications. Number of geometric multiplication. So friends, number of Jordan block of lambda is number of geometric multiplication of lambda. So whatever I see, we see that this case, in this case, hold this. Otherwise, this case we do not follow this property, because rank of a square is equal to 0. So in this case, you get this property is correct. So friends, my answer should be number of Jordan block is 2. 2 is my answer. I hope I can clear concept, because you must remember number of Jordan block equals to geometric number of Jordan block of lambda is equals to geometric multiplicity of lambda. Next problem, friends. Next problem we are going to solve. Next problem. Let t equals to -1, 1 and -1, 1 if the function f such that t tends to r fxy equal to x square minus y square and x square plus y square whole square. So then whatever we get, f is continuous at 0, 0, both the function order partial derivative of f exist 0, 0, and double integration mod of fxy is finite, and this type of question is coming GATE examinations, I hope. So friends, whatever my region is, if you see, if I draw, you can see that my region is a square. This is my region. So in here, whatever you get, -1, 1 and this is 1, 1, this is 1, -1, and this is -1, -1. This is my region. This region, and if the function f such that d tends to r is defined by fxy equal to x square plus y square. So f is continuous at 0, 0. Simple way, friends. F is continuous or 0, 0, that I will find out. F is equal to fx is equal to x square minus y square divided by x square plus y square, and x is equal to r cos theta, y is equal to r sin theta. So friends, whatever we get, fx is equal to cos 2 theta divided by r, r tends to r square. Sorry, it is r square, x square plus y square whole square. So cos 2 theta, r tends to, that is infinity. R tends to 0, so r tends to 0, so it is infinity. So it is not continuous at, f is not continuous at 0, 0. Simple. And similarly, fx is order of partial derivative exist, so this is also wrong. Why, friends? Because as it is not continuous, so no chance as it is not continuous, so differentiability no chance, it is not continuous. Cont means every differentiable function is continuous. So in this logic we do not get it is not continuous. Next friend, next question is double integration d mod of x comma y dx into dy. So friends, whatever we get the value is -1 to 1 and -1 to 1 cos 2 theta divided by root over cos 2 theta divided by r and r into dr into d theta. So according to this r cut, so this value is finite, and it can be written this way. When I will write, then it is 0 to 2 pi and 0 to 1. So this value is finite. And again, next, whatever we get, friends, and again, when they ask that it is not half, so just asking that d mod of fx comma y dx 0 dy 0 to 1 0 to 2 pi. So whatever we get, friends, we get simple cos 2 theta by r dr into d theta. So this value is log r, and 0 to 1 means, and another factor is 0 to 2 pi cos 2 theta, and where log 0 is equal to infinity, so it is infinity, not finite. So my answer C is correct, D is wrong. Next we go to solve number 3 from complex analysis question. Let's start to read these questions. If fz equals to uxy plus ivx x plus iy x and y real number is non-constant analytic functions, friends. Must remember, on the complex plane C, let ux and vx denote the first order partial derivative of uxy fz, real fz, and vxy imaginary fz. So with respect to real variables x and y, and g1z is equal to ux comma x comma y plus I into uy x comma y, and g2z is equal to this is. So g1z is analytic on C, and g2z is not analytic, and g1z is analytic in C, and g2z is analytic. This is the question. So friends, very interesting question, friends. So whatever it is say, fz equals to non-constant analytic function. Fz is non-constant analytic function, friends. First factor. So as analytic analytic, so ux, uy, vz, vx and vy both are continuous and infinite differentiable. So it is continuous and differentiable and differentiable. So friends, analytic means analytic function equals to infinite differentiable. Infinite differentiable. So friends, let's start to discuss g1z. G1z is equal to ux x comma y minus I u y x comma y, and g1 and g2z is equal to ux vx x comma y plus I vy x comma y. You will see these two type. So analytic function is infinite differentiable. So f dash z is equal to also ux plus I vx by the CR equations. What is the CR equations, friends? Ux is equal to vy and vx is equal to minus uy. So f dash z can be written this way, that ux minus I uy. So this is the first option. This value is g1 z. So it is analytic. But next problem is, friends, vx xy and vy. So whatever you see that g2z is equal to vx plus I vy. So I f dash z equals to whatever we get, I ux plus uy. You get I ux plus uy. You get, so this value equals to I f dash z is equal to I ux I uy is equal to minus vx and ux I ux is equal to vy. So this value is minus. So it is the must remember that f dash z is equal to f dash z analytic. But if conjugate analytic. So friends, I f dash z now minus I f dash z conjugate is equal to vx plus I vy. So if I will multiply with minus, then whatever we get, this value is vx plus I vy, not plus. This value is minus I vy. So conjugate function is vx plus I vy. This is also analytic. This portion is analytic. So conjugate also analytic. Conjugate is analytic. So that the function is constant. So that function is constant. So that f dash z is equal to c. So fz is equal to az plus b. But it is not so. It is possible g2z is analytic when g2z is analytic when g2z is polynomial functions, but it is not possible. So only possible is g1z is analytic, but g2z is not analytic. It is correct. And baki and another all the option is wrong. So friends, now we are solving next questions. Next question is very interesting questions, friends. This question is an is equal to n equals to 1 be a sequence of real numbers satisfies a1 greater than equals to 1, n plus 1 is equal to n plus 1. So friends, whatever we have n plus 1 greater than equals to n plus 1. So this is increasing functions, and as increasing as a1 greater than 1. So increasing functions, so n summation n is divergent because why? Because n tends to infinity, so it is not tends to 0. So friends, and n is bounded, this is not possible. Number 2 is wrong, and the series an squared is convergence, and the series an is convergence. So friends, an is convergence, this is not possible. How? Because suppose an equals to n, so suppose an equals to n, then it is not possible that 1 by n is divergence dgt. So this is not possible. According to the question, an plus 1 greater than equals to an, must remember friends, greater than an, so we cannot choose that an is equal to root over n, because another factor, that obviously it is one difference. Whatever we get the possibility is an plus 1 divided by n greater than 1. This is possibility, and the difference an plus 1 minus n obviously greater than 1, greater than equals to 1. So we can't choose square root, means root over n. This is not possible because a1 is greater than 1. This condition will not hold. Root over n by root 3 by 2. So n is, but in case of n, sequence is n, then this possibility can be hold. So friends, 1 by an square is convergence. The series 1 by an square summation n equals to 1 to infinity 1 by n square is convergence. Summation an square is convergence because it is decreasing functions, decreasing function, and 1 by an square tends to infinity. So as n tends to infinity, so possibility only convergence, otherwise not possible. And next problem is very simple problem, friends. This problem is based on comparison test. Friends. Comparison test means if un summation un greater than summation vn is CGT, summation vn is CGT, that implies summation un is CGT, because as it is greater than, but converse is not true. Means if un is, so friends, whatever you see that p greater than q, so mod of xn to the power p greater than mod of xn to the power q, as xn p greater than 0, as xn p summation xn p is finite. Finite means CGT. So friends, this equations will be hold. This equation is CGT, so that mod of xn less than 1 as p greater than q, so xn greater than xn to the power q. So this equation, according to these equations, that mod of xn is CGT, that implies mod of xn n to the power p is CGT, so that implies is CGT. So these equations is correct. Number A is correct, and similarly number 2 is, option 2 is false, as is the less of the infinity 1 less than p. And number 3 give any 1 less than p less than q infinity such that xn mod of xn p is equal to infinity, and that implies xn q to the power infinity. So friends, same case. Number 3 is wrong, because xnp to the power q is infinity, so xnq to the power not infinity, this is correct. This is wrong. Number 3 is wrong. Number 3 is wrong. Number 4 is correct. Because as the mod of xn whole to the power p less than infinity and mod of xn less than in case that q greater than p, so mod of xn whole to the power p greater than mod of xn whole to the power q. So this case you see that whatever you see that x mod of xn the mod of xn q and mod of xn p, mod of xn whole to the power p equals to in less than infinity, but mod of xn whole to the power q equals to infinity. So this is the comparison test, friends. If smaller is convergent, smaller term is convergent. If bigger term is convergent, means largest term is convergent, then smaller term is also convergent. But if smaller term is divergent, then largest term is also divergent. Next problem is very nice problem, friends. Next problem is this problem is GATE 2021 is coming. GATE 2021, that fz equals to e to the power z, z belongs to c by 0, and rn equals to z equals to x plus. So whatever this case is, this is the first case, another case is this is the second case. This is 1 by n plus 1 and this is 1 by n. This is the rectangle, friends, and you will see that this is my graph. So whatever you see that closure of f r n plus 1 does not equals to f r n n rn. So you see that rn plus 1 does not a subset of rn. So if r n plus 1 closure does not equals to f rn. So this is the main NBD deleted. NBD is 0. So friends, in this way you see that this option A is correct. Now e to the power 1 by z is essential singularity. E to the power 1z is essential singularity. So whatever we get, we know the Weierstrass theorem. What is the Weierstrass theorem? Casorati Weierstrass theorem, Weierstrass theorem, there is no limit, does not exist in here. So closures of f r n plus 1, closure of L is does not equals to f r n n, as if neighborhood of z0 it tends to dense in C2, and if closure of f n z0 is C infinity, because we know the Weierstrass theorem, there is no particular limit for essential singularities. We get a lot of limits, so that's why it is dense in C. Number second, f r n, closures of f r n plus 1 equals to number 2 questions, f of r n divided by r n plus 1. In both cases, here it is C and here it is C, so C by C equals to empty, and this is, and this value is equals to empty, and this value is, suppose this is Rn, this portion, these portions, closures of this portion, so it is not empty, so it does not equals to hold, so that friends, whatever you see option B is false. Now we will see option C and option D. If intersection of n equals to 1 to infinity Rn, this value is phi, and intersection of f Rn closures n equals to 1 to infinity equals to C, so this is does not equals to, so this option is also false. So friends, why it closures is total C? Because in complex analysis Weierstrass theorem, we know that limit is in everything, no particular limit. We can get a lot of path and we can get a lot of limit, infinity limit. In case of number D, closures of f Rn equals to closures of f Rn plus 1, because f Rn, closures of f Rn by Weierstrass theorem, C infinity, and f Rn plus 1 closures is equal to C infinity. Closures means set of all limit points, set of all limit points. is called closures. Now friends, another question is very fantastic. This question is the last questions. This question is m cube is equal to I and mv does not equals to v. That implies 1 is not eigen value, so rank is even number. As m cube equals to I, so m square is equal to m inverse non-singular matrix. Non-singular matrix. So that whatever we get, m square is equal to m inverse non-singular matrix. So whatever we get nullity is 0, hence rank of m is equal to n equals to even number divide by 2. So my answer is correct. N is divisible by 2. Another is m has real number. This question is m has real eigenvalue. This option is wrong. This option is wrong. And n is divisible by 3. This option is also wrong. So only m plus m inverse, as m cube equals to I, so m square plus m plus I equals to 0, so m square plus m inverse plus m equals to minus I minus 1 is eigenvalue, which is real. So option B is correct. Sorry, option B is correct. So my answer is B and C. Thanks for watching, friends.